Hello friends, welcome you all. So in this video, we will take another conversion which is PDA to CFG. So in last lecture, we have discussed CFG to PDA conversion. Now we will discuss PDA to CFG conversion, the reverse conversion. So for this, I have taken one PDA as example here, and I will tell you how these transitions of PDA are converted into equivalent grammar. So before starting the conversion, I will tell you something important about it. So as you can see, friend, in PDA there are 7 tuples: Q, sigma, delta, gamma, then delta, then Q0, then Z0, and then F. So all these tuples are there in PDA, and in grammar we are having 4 tuples: V, T, P, and S. So in this particular conversion, we are converting 7 tuples into 4. So as you know, friend, in grammar, we have set of variables, set of terminals, set of production rules, and set of, start variables. So S is a start variable here. So remember, friends, when we are converting any PDA into CFG, then the set of variable will have one starter variable and some other variables. So only the start variable here will be represented with s. Start variable will be represented here as s, and remaining all variables will be represented in a specific format. So that format would be like this. So here the name of variable would be represented as any state from set Q, any symbol from gamma, and any state from Q again. So in the form of this triplet, the variable name would be represented. So when we are converting any PDA into CFG, so only the start variable would be represented as single alphabet. Remaining all variables would be represented as a triple like this. So these triple will have the format Q, gamma, and Q. That means one member of Q would be there. For example, I can have here Q0. I can have here Q0, then Z0, and Q0. So this would be considered as a variable name. So this is the format of triple, and this is one instance of triple. That means this is the name of one variable. So in this format, we will represent all these variables of grammar except the start variable, which is represented as single alphabet. So now I will take all these transition as example, and I will tell you how to convert this particular how to convert this particular PDA into CFG. So now friends, as I told you, I have taken this particular PDA as example, and if you can remember, if you can see the transition of this Pushdown Automata, then you can understand it is representing a to the power n and b to the power n, where n is greater than or equal to 1. So this particular language is represented as PDA like this. So now we will convert this particular PDA into CFG. So now I will tell you how this conversion is done. First of all, in any CFG, you will have one start variable, and definitely there will be some production of start variable also. So here, as I told you, only the start variable in this grammar is represented as single alphabet, which is S, and all the production of S you can create like this. So S will generate only the variables. All the production of S would be unit production. Unit production, that means both sides will have only one variable. So how these productions you can create, so that I will tell you. So for all production of start variable, you need to have the formula format like this. So as our initial state is Q0, you can see here in first transition, the current state is q0, so it would be considered as initial state. So initial state is q0, this is initial stack symbol, so this would be the format of all production of star variable. Now here I have mentioned p, so p can have any value from capital Q, where p has p is any value from capital Q. So one by one we can have all states of Q here as in place of P. So in this particular PDA we have two states, one is Q0 and other is Q1. So here Q is having only two members as Q0 and Q1. So once I will take Q0 in place of P, and then I will take Q1 as in place of P. So here in this particular example, start variable have two production. Start variable have two production. Now how these what these productions are, so I will tell you. So these productions are the production of start variable. Here I can mention as Q0. Once I replaced P with Q0, and then it will have one more production. So that different production I can represent with the help of this bar, and then it can have Q0, sorry, Q0, Z0, and Q1. So these two production will be there for star variable. As we have only two states here, so one by one at last position we will push all the states one by one, and we will create that many productions of star variable. So these two productions are there for star variable in this particular example. Now I will create more productions with the help of all these transitions. So I hope, friend, till now it would be very much clear how to create start variable, production of start variable, and now I will tell you how we can convert all these transitions into production rules. Now I will take one transition rule at a time, and I will convert one transition into corresponding productions. For now I will take this particular transition to convert it into production rules. So I will show you how to convert this particular form transition, any transition, into a Z0. Then it gives us Q0 X Z0. So friends, this is first transition I have taken, and now I will convert this transition into equivalent production rules. So for this particular transition, you can create more than one production rules, and all these production rules will be in GNF. All these production rules will be in GNF. So now we will see how we can create the transition. So as I told you, you will have four different production for corresponding to this transition rule. So how these production rules will be created, that I will tell you. So when you are converting any transition rule into production, so you will have all production in GNF. And how many in GNF we have production like variable. Now how many variable will be in the right hand side? So as many symbols you have in the string of grammar stack symbol, that many variables will be there in the right hand side of each production. So here we have two symbols in the string of grammar symbol. So each production rule will have two variable in the right hand side. So these would be like this. Now as I told you, so now how these what kind of production would be there corresponding to this rule. So as now you can understand it very easily. Now this particular state will come here, this particular symbol will go here, this particular symbol will come here, and this particular state will come here. In all the production these will be common. So this particular symbol would be there, and this particular symbol would be there. So now you can fill all these values. So it would be Q0, Q0, and these values will be common in all four production. So Q0, that would be Q0. Then it is Z0, then it is Z0, then it is Z0, then it is Z0. Then here it is A, A, and A. Here it is Q0, then Q0, then Q0, and Q0. And then here it is X, 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 and X. Here it is Z0, Z0, then Z0, then Z0. So this. Now we have, see, for variable, as I told you, there will be triple form, like one member from Q, then one member from gamma, then another member from Q will be there. Here also we have two variables here, and here we have one variable. Now the name of this variable is not completed yet. So now I will tell you how to fill all these product positions. So now here you have two different state. You have two different state which are Q0 and Q1. Q0 and Q1. So, and you have four positions here. 1, then 2, and this, so you have four positions here. 1, 2, 3, and 4. So now, how to fill these positions, that I will tell you. So whatever comes in this position, the rightmost symbol of left hand side variable and rightmost symbol of right hand side variable would be same. So this would be, whatever comes here, it will be copied here. Whatever comes here, it will be copied here. And what in adjacent positions, the same state would be there. In these adjacent positions, same state would be there. So to fill these all these four places, we need two values. To fill all these four places, we need two value, because the common value will be here and common value will be here. So we need two values. Now you can see, my friend, here you have two different states. Now if I tell you to create combination of these two states, so how many combination you can create? With two states, you can create four different combination. So first combination would be Q0, Q0, then Q0, Q1, then Q1, Q0, and then Q1, Q1. So now you can use, in one production rule, you can use one combination. So if you are placing here, first we are using Q0, Q0. So I am writing here Q0. As I am writing Q0 here, so same value would be copied here also. So it will also be having Q0. Now here I am writing Q1, Q0 again. So whatever I am writing here, same value would be copied here also. So now we have filled all these four positions. Now in next production, what we can have, we can use this next combination. So here I can use Q0, and if I'm writing here Q0, so here also there will be Q0. Now this time I'm writing Q1, so I'm writing Q1 here, so Q1 will be copied here also. Now in third production rule, we can use third combination. So here I can write Q1, so it will be copied here also. Here I can write Q0, so it will be copied here also. Now in last production rule, we can use fourth combination. So Q1, then Q1, and then Q1, and then Q1. So now all these four productions are completed. Now you can understand, see, these four productions are of same format. All productions are having exactly two variable in the right hand side, and these are equal to the number of symbols in the right hand side string of grammar stack symbol. So this is how you can convert any transition into corresponding productions. So I hope this would be very much clear. Now I will take, see, we have converted only one transition into production rule. Now we will take this example, then this example, then this. So all all transition rules will be we will be converting one by one into corresponding production rules. So I hope this process would be clear now. Now I will take next uh, transition rule as example. So now, friend, you can see I have used second transition rule here. I have used second transition rule here. Now, here in this transition also, we have two symbols in the right hand side string. So we will be having and two states are there in the PDA. So we will be having same four production rules corresponding to this transition. And in each production rule, there will be two variable in the right hand side. And this is how you can convert this particular transition into corresponding production rules. So with this this transition also we have we have created these four rules. So I hope it would be very much clear to all of you. And now I will take next rule as example. Now I will take next rule as example, and I will convert this rule to uh, production rules. Here I can have Q0 be X. Then we are having Q1 epsilon. Now you can see in the same way as we are doing, we have done this, so we will convert this also. So this would have, see, as you have no variable in the right hand side string, so in all production you will not have any variable. Now in this case, if you are having epsilon in the right hand side of any transition rule, then it will have only one production, corresponding production, and that would be created like this. So this state would be coming here Q0, this X would be coming here X, and this state would be coming here Q1. This gives us this B would be coming here in the right hand side. Now, as we have epsilon in the right hand side string of stack symbol, so we will not have any variable in the right hand side. So corresponding to this transition rule, this is the production rule. So I hope it would be very much clear. Now how we have converted this. So this state has come here, this symbol has come here, this symbol has come here, and this symbol has come here. Now corresponding to this transition, I can have Q. Now I will take this particular transition. So I can use Q0, then B, then X, then Q1, sorry, Q1, B, X, and then Q1 and epsilon. So corresponding to this, I can create Q1, X, Q1 gives us B. So this is only one production rule corresponding to this transition. Now, in this particular, corresponding to this particular production rule, I will create transition, sorry, corresponding to this particular transition rule, I will create the production now. So I'm directly writing the production rule. So it will have Q1, then Z0, then Q1, and it will gives us, this will be coming at right hand side, so it will gives us epsilon. So this is how we have converted all transition rules of PDA into corresponding productions. So I hope that process would be very much clear to all of you, and if you have any doubt, you can always write to me in comments. Now corresponding to all transition rules, we have created production, but this grammar may have some useless variables and useless productions. So you need to simplify this grammar. This is not final grammar, so you need to simplify this grammar. But if you are asked to convert any PDA into grammar, then you can consider it as completed. So now when you simplify this grammar, then some useless productions and some useless symbols will be removed from this grammar, and then you will have the final grammar. So friends, we have got all these productions corresponding to all PDA transitions. Now, because of some space, I have accommodated it like this. So I hope it is visible to everyone. Now, you can see we have so many triplets. So all these triplets representing one variable. Now, different triplet we can represent with different symbolic name. So like here for Q0, Z0, Q0, I am representing it as A. Then Q0, Z0, Q1, I am representing it as B. Now Q0, Z0, Q0, it is also we have already given its name as A. Now Q0 x Z0, this is new variable, so I can represent it as C. Now Q0 Z0 Q0, we have already given one name, so it would be A. Then Q0 Z0 Q0, again it is A. Then Q0 x Q1, it is new variable, so I can represent it as D. Then this is again a new variable, so I can represent it as E. Then this is Q0 Z0 Q1, it is B. This is how we have named all these variables. So here Q0 Q1 x Q1, it is new variable, so I can write it like F. Then Q1 Q0 Q1, so it is again one variable, new variable, so I can write it as G. Now here I have Q0 x Q0. So we have already given this variable a name C. Then we have Q0 x Q0. Again we have C, and Q0 x Q0, again we have C here. Now we have Q0 x Q0. So again we have C here. Q0 x Q1. So Q0 x Q1. So we have given it as name D. Then Q1 x Q0. Q1 x Q0, we have not given any name here. So I can represent it as H. It is new variable. Now Q0 x Q1, Q0 x Q1. So we have already given this name as a D, and Q0 x Q0. So we have already given its name as C. Then Q0 x Q1, Q0 x Q1, we have already given the name D. Now Q0 x Q1, again it is D. Then we have Q0 x Q1, so it is D again. Then Q0 x Q1, sorry, Q1 x Q1. So it is new variable, so I can write it like H, then I. Then Q0 x Q0, Q0 x Q0, we have already given its name as C. Then Q1 x Q1, so we have already given its name as I. So I can write it I. Then Q1 x Z0 Q1. Q1 Z0 Q1. So we have already given the name as a Z. So now we have replaced all triplets with the symbolic name. So I can rewrite this grammar as gives A, B. Then A gives small a, capital C, capital A. Then A, one more production of A is there. It is small a, capital D, small capital E. Then we have production of B. So B gives A, then C, small capital C, and then B. Then we have one more production of B as small a, capital F, capital G. So we have here F. We have here F. So friends, you can check. I have shown you the process. Now you can do it, and very carefully you can do it, right? Now, next production of C here, C as small a C C. Then C as one more production of there, C C gives small a, small d, small capital H. Then we have production D. D gives small a C D and small a D F. Then we have C gives one more production of C. We have B. One more production of F. One more production of F. We have B. F gives B. And one production of G. We have epsilon. So now you can see, my friend, this is our grammar. Now you can simplify this grammar. You can identify the useless variable and useless production here. Now, if any variable you can see in the right hand side only, but it is not appearing in the left hand side, then you can simply consider this variable as useless variable, and you can remove all production of that particular variable. So here you can see, my friend, E and H, two variables we are having which are not appearing in the left hand side of any production. So I can simply remove these two productions from here, and as the H and as these two productions are having useless variable, so we can remove this useless variable and its productions as well. So these two productions will be removed. Then G we have as epsilon. G is epsilon production, and we have only one production where G is at right hand side. So we can simply remove this production, and we can replace this G with epsilon. So if we replace this G with epsilon, so it will be as a F. So this production you can also remove. Then all productions you can see here as A and B, then A, B, C is there in the right hand side, D is there in the right hand side. So you can simplify this grammar. So we have already seen the simplification process in very much detail. So you can use all these simplification process and you can simplify this grammar. So this is how a PDA is converted into equivalent CFG. Now I will discuss something very important about this conversion. So now, in case you are having this kind of production like Q0, it is Z0 and it is Q. We are having Q0, we are reading A, Z0 is the stack top, and then we are having Q1, then we are having XZ0, sorry, XXZ0. Now this time you have three symbols in the right hand side string, and you have two states clearly mentioned in this particular transition. Now you can, how many productions you can create corresponding to this particular transition. So now we have three positions in the right hand side. As we have three symbols in the stack string, then we will have three variables in the right hand side of each production. Now if we have three variables in the right hand side, then format of production would be like this. So it would be like A, then. So now you can see you have, and now this position will be filled with this would be filled with this, and this would be filled with, we have already filled. Now this would be filled with this, then this X, then second X, and then Z0 will be coming like this. Now we have six different position 1, 2, 3, 4, 5, 6. Now, as we did in last example, so we will do the same thing in this example. So now the last symbol of left hand side and the last symbol of right hand side would be same. So if you are having here Q0, then it would be copied here also. And two adjacent position will have same value always. So these two will have same value, these two will have same value, and these two will have same value. So to fill all these 6 positions, we need 3 different values. Now, how these values would be coming? So you can see how many states are there in this transition. So 1 and 2 states are visible. So we have 3 positions, and to fill each position we have 2 different values. That means Q0 and Q1. Both these value you can use to fill each position. Now you can have 8 different combinations. So like Q0, Q0 and Q0, then Q0, Q0, Q1, then Q0, Q1, Q0, then Q0, Q1, Q1, and then for production Q1, Q0, Q0, then Q1, Q0, Q1, and then Q1, Q1, Q0, and then last is Q1, Q1, Q1. So these 8 combinations you can use in 8 different production that you will create using this particular transition rule. So this is how you can create different 8 different production for corresponding to this transition rule. Now, if some transition rule is given to you, then how would you identify how many productions we can create with this? So now I will tell you the formula. So suppose you have n number of states in the PDA and m number of symbols in stack string. Then you can create n to the power m different production rules corresponding to this particular transition. So this is the formula to identify the number of production rules corresponding to particular transition or particular PDA. So I hope it would be very much clear now. Then if you have any doubt, you can always write to me in comments and I will definitely reply your comments. Thank you so much.